I recently purchased a 1.5 Farad 5.5 volt supercapacitor and will be testing it by driving an LED using the capacitor in this video. Remember that supercapacitors have polarity, and in this particular model, the polarity is identified by the plus and minus etched on the top and bottom of the capacitor body. Let us look at the schematic of the LED-based circuit that will be driven by the supercapacitor. It consists of a supercapacitor of 1.5 farads with a peak voltage of 5.5 volt in parallel with a 100 ohm current limiting resistor and a quarter watt white LED. A variable power supply set to 3.6 volts and with a peak current output at 1 amperes will be used to drive this circuit. We will be starting out with the basic test circuit. I have assembled the schematic on a breadboard like being shown here. Remember that LEDs have polarity too. We can see that the LED lights up once the power is applied to the circuit. From the power supply, we can see that this circuit is using 20 milliamperes. When we disconnect the power from the circuit, we observe that the LED stops glowing almost immediately. We will now be adding a supercapacitor to this circuit. Follow the polarities carefully as discussed at the start of this video and connect the supercapacitor to the circuit. Upon supplying the power to the circuit, we can observe that the LED glows up a tiny bit slower than in the earlier circuit without the supercapacitor. Observing the power meter on the supply, we see that a lot more power is being consumed. The capacitor starts absorbing all the power it can get and gradually reduces and finally reaches the earlier 20 milliamperes after a period of time once the capacitor has been fully charged. Checking the voltage across the supercapacitor leads with a multimeter, we see that it now has a peak voltage of 3.5 volts. On disconnecting the power supply lead, we observe that the LED will continue to glow brightly. Measuring the voltage of the supercapacitor, we now observe that the voltage has fallen to around 2.9 volts. This LED will continue to be on with an acceptable brightness for more than 5 minutes. To see how amazing this is, I will replace the supercapacitor with an electrolytic capacitor of similar volume but far lower capacity at 470 microfarads. Remember that electrolytic capacitors have polarity too. Follow the correct polarity and replace the supercapacitor with the electrolytic capacitor. Upon supplying power, we now see that the LED lights up faster because of the lower capacitance. But upon removing the power source, the far lower capacitance cannot sustain the LED power requirement and the LED brightness decreases almost immediately within a second.